Hi everyone, it's good to have you back on Step by Step Academy. My name is Akin. In today's video, you and me together we will learn how to perform the division operation in module arithmetic. We will see how to divide numbers in any given mode, and there are two different methods that I'll be showing you on how to perform the division operation in module arithmetic. The first method is what I refer to as the multiplicative inverse method, and the second method is what I call the algebraic method. Now let's begin right away with the first example before us. We have 4 divided by 3 in mode 5 using the first method, that is the multiplicative inverse method. We'll begin first by trying to understand what the multiplicative inverse method is all about. Suppose I ask you, what is the multiplicative inverse of 5? Normal mathematics. The multiplicative inverse of 5 is the number that will multiply 5 to give us 1. Obviously, that number is 5 to the power of minus 1. Because 5 to the power of minus 1 actually means 1 over 5. And 5 divide 5 here will get 1. Therefore, the multiplicative inverse of 5 is 5 to the power of minus 1. Alternatively, if I ask you, what is the multiplicative inverse of 5 to the power of minus 1? Obviously, the answer will be the opposite of what we have initially, which is 5. So 5 is the multiplicative inverse of 5 to the power of minus 1 because these two numbers will multiply each other to give us 1. Therefore, let's draw a conclusion. In normal mathematics, the multiplicative inverse of any number is the number that can multiply the given number to give us 1. Now, the same concept is applicable when you have other modes other than mode 10. Your normal mathematics is in mode 10. Now, other than mode 10, the same concept is applicable to every other mode. Now, let's see now how to apply the multiplicative inverse method in solving the problem or in dividing the numbers before us. The first thing we want to do is to write this number or this expression in multiplication form. 4 divided by 3 can be written as 4 times 3 to the power of minus 1 in mode 5. That's because 4 over 3 is the same thing as 4 times 1 over 3, and 1 over 3 is the same thing as 3 to the power of minus 1. So 4 over 3 can be written as 4 times 3 to the power of minus 1. Now, objective now is to find the multiplicative inverse of 3 to the power of minus 1 in mode 5. Please note, in mode 5. Now, multiplicative inverse of 3 to the power of minus 1 is the number that will multiply 3 to the power of minus 1 in mode 5 and give us 1 in mode 5. So let's find out what that number would be. Actually, that number must fulfill two conditions. Number 1, the number must be divisible by 3. At the same time, the number must leave a remainder of 1 when divided by 5. I take that again. The multiplicative inverse of 3 to the power of minus 1 must fulfill two conditions. Number 1, it must be divisible by 3. And number 2, it must leave a remainder of 1 when divided by 5. Now let's take a look at numbers that are divisible by 3. We have 3, 6, 9, 12, and so on. Now all these numbers fulfill the first condition. They are all divisible by 3. But not all of them will leave a remainder of 1 when divided by 5. Out of this list of numbers, only 6 will leave a remainder of 1 when divided by 5. Therefore, the number 6 fulfills the two conditions. It is divisible by 3 and is going to leave a remainder of 1 when divided by 5. Therefore, we can write 1 mode 5 as 6 mode 5. 1 mode 5 is the same as 6 mode 5 because 6 divided by 5 will give us a remainder of 1. Now, the next step from here now is to now get the multiplicative inverse of 3 to the power of minus 1, which we will do by dividing both sides of this equation by 3. So 3 cancels 3 here, 3 here is 2. So we have 3 to the power of minus 1 equals 2 mode 5. Therefore, the multiplicative inverse of 3 to the power of minus 1 in mode 5 is 2 mode 5. Now that we have found out what the multiplicative inverse is, let's go back now to our expression, to this expression. So here we come back here now, we have 4 times 3 to the power of minus 1 in mode 5. Now we know what 3 to the power of minus 1 is in mode 5. It is 2 mode 5. Therefore, replace 3 to the power of minus 1, replace it with 2 mode 5. Now from here, 4 times 2 will give us 8 mode 5. And of course, from here we'll simplify further. 8 mode 5 can be simplified further. That will give us 8 divided by 5. So 5 will go in 8, 1, and give us a remainder of 3. This remainder of 3 is our final answer. Therefore, the answer to 4 divided by 3 in mode 5 is 3 mode 5. 3 mode 5. So this is how you apply the multiplicative inverse method in dividing numbers in any given mode. Now let's go to the second method, which is the algebraic method. Now for the algebraic method, we have 4 divided by 3 in mode 5. We don't know what the result will be when 4 divide 3 in mode 5. So let's apply algebra. Let x be the answer when 4 divides 3. When 3 divides 4 in mode 5. Now the next step I'll do here is to cross multiply. So this will give me 3x is equal to 4 in mode 5. Now this expression that we have here, from this point forward, we're supposed to divide both sides by 3. However, there's a challenge here. 4 on my right is not divisible by 3. So what do I do? Not to worry, there's something we can do. Now let's rewrite this expression in this form. 3x is the same thing as 0 plus 3x. 4 mode 5 is also the same thing as 0 plus 4 mode 5. Right? After all, when 0 is added to any number, that number remains, or that expression remains unchanged. Now, but why do we need to add 0, and what is the use of the 0 we have just added? The use of that 0 is this. On my left, 0 plus 3x will remain 3x. But on my right, this 0, I can turn this 0. I can rewrite this 0 in mode 5. So what is 0 in mode 5? Obviously, that is 5 mode 5. 0 is the same as 5 mode 5. Then plus 4 mode 5. Now, why do I need to do this? I needed to change this 0 to 5 mode 5 because I need a number that is divisible by 3. And I see that if I change 0 to a multiple of 5, I can add that 5 to 4, and that will give me 9, which is a number that is divisible by 3. So 5 plus 4 will give me 9 in mode 5. Therefore, I now have 3x is equal to 9 mode 5. So divide both sides by 3. So x is going to be 3 mode 5. So you see, my friend, we have the same answer as we did using the multiplicative inverse method. So this is how you divide numbers in any given mode, using either the multiplicative inverse method or the algebraic method. Sometimes a multiplicative inverse may not exist for a particular number in a given mode, and as such there will be no solution using the multiplicative inverse method. However, while the multiplicative inverse method may not yield a solution, the algebraic method may. An example of such instance is what we have before us. 6 divide 2 in mode 8. Now let's see, using the multiplicative inverse method, the first thing is to write this in multiplication form. So this will be 6 times 2 to the power of minus 1 in mode 8. The next step will be to look for multiplicative inverse of 2 to the power of minus 1. and that's a number that will multiply 2 to the power of minus 1 in mode 8 to give us 1 mode 8. So let's see if we will get such number. Now that number must fulfill two conditions. Number one, it must be divisible by 2, and it must leave a remainder of 1 when divided by 8. Now let's look at numbers that are divisible by 2. We have 2, 4, 6, 8, 10, 12, 14, 16. Now if we start from 8, 8 divided by 8 will leave us with a remainder of 0. 10 divided by 8 will give us a remainder of 2. 12 divided by 8 will give us remainder of 4. 14 divided by 8 will give us a remainder of 6. And 16 divided by 8 will give us a remainder of 0. So you see we are back to 0. So we'll keep having 0, 2, 4, 6, 0, 2, 4, 6. So we will never get a remainder of 1 in mode 8. Therefore, the multiplicative inverse of 2 to the power of minus 1 does not exist in mode 8. Therefore, there will be no solution using the multiplicative inverse method. Now let's try the same problem using the algebraic method. We have 6 divided by 2 mode 8. Now let x be equal to 6 over 2 in mode 8. The next step is to cross multiply. This will give us 2x is equal to 6 mode 8. And then the next step is to divide both sides by 2. So 2 can divide 6, therefore we have a solution using the algebraic method. We have x is equal to 3 mode 8. So we have a solution of 3. So why the multiplicative inverse method yielded no solution? The algebraic method yielded a solution of 3 mode 8. So as a rule of thumb, I encourage you to always use the algebraic method first. There are instances where both the algebraic method and the multiplicative inverse method will yield no solution. For instance, 14 divided by 3 in mode 9. Using the multiplicative inverse method, this can be written as 14 times 3 to the power of minus 1 in mode 9. Now, the next step is to find the multiplicative inverse for 3 to the power of minus 1. And that is a number that will multiply 3 to the power of minus 1 in mode 9 to give us 1 in mode 9. So let's see if we will have such number. Remember again that such number must meet two conditions. Number 1, it must be divisible by 3. Number 2, it must leave us a remainder of 1 when divided by 9. Let's see if we have such number. The first multiple of 3, or the first number divisible by 3, is 3. We also have 6, then 9, then 12, then 15, 18, 21, and so on. Now, if 9 divide 9, we'll get a remainder of 0. 12 divide 9 will give us a remainder of 3. 15 divide 9 will give us a remainder of 6. And 18 divided by 9 will give us a remainder of 0. 21 divided by 9 will give us a remainder of 3. So you see, we keep having a cycle of 0, 3, 6, 0, 3, 6, 0, 3, 6. So we will never get a remainder of 1 in mode 9. Therefore, 3 to the power of minus 1 does not have any multiplicative inverse in mode 9. And as such, there will be no solution to this problem. Now let's see if we have a solution using the algebraic method. 14 divided by 3 in mode 9. Let x be equal to 14 over 3 mode 9. The next step is to cross multiply. This will give us 3x. That's 3 times x. 3x is equal to 14 mode 9. Now, we are to divide both sides by 13, but unfortunately 3 cannot divide into 14. So what do? We'll check for multiples of 9 that we can add to 14 to make 14 divisible by 3. Let's see if we have such multiple. These are multiples of 9. You have 9, 18, and then you have 27, 36, you have 45, and so on. Now if we add 9 to 14, that will give us 23. 23 is not divisible by 3, so that will not work. The next multiple is 18. If we add 18 to 14, we will get 32 mod 9. 3 divide 32, that is impossible. 3 cannot divide into 32. The next is 27. 14 plus 27 will give us 41. 3 is not 41 rather is not divisible by 3. The next multiple is 36. 14 plus 36 will give us 50. 50 again is not divisible by 3. The next is 45. That will give us 59. 59 also is not divisible by 3. So if we continue, we will never get a multiple of 9 when added to 14 will make 14 divisible by 3. So as such, there is no solution. So this is an example of a question where both the algebraic method and the multiplicative inverse method will not yield a solution. Thank you very much for your time. This is how you divide numbers in module arithmetic. I'll see you in the next video.